Let's start with a hypothetical situation. Your TV just broke.
Oh, Mama!
And you've got to go buy a new one. You walk into an electronics store, or you look at some advertising materials. What buzzwords are TV makers using to try to sell you their latest and greatest? If you were to do this right now, you'd probably see a plethora of acronyms hawking the latest display technologies, QLED, micro-LED, nanocell, to name a few. But if we travel back a few years, we have smart TVs with AI, quote unquote. Before that, the shift to 4K display panels. Earlier, high refresh rates, 120 Hz. Earlier, just large size. Even earlier, Full HD was the feature. And then the transition from old school TVs to flat screen. Every year, there seems to be some reason concocted to convince you that your current TV isn't good enough. In 2010, there was nothing bigger than 3D. 3D was everywhere. TV, movies, games. And smack in the middle of this 3D boom came this little, forgotten piece of tech. Design of Things 24, Fujifilm Finepix Real 3D W3. This is a really interesting device for a number of reasons. Let's start by looking at the design of the front face. Starting in this bottom right corner, we have some branding. Finepix, written in all caps, and Real 3D, done in a slanted version. Other than the slant, which conveys forward motion, making it feel futuristic, there's also this little gap in the top left of the D, which adds some character to the logo. The logo is printed on a dark blue brushed metal. Above this, we have another face, which is also metal, but a matte finish. The Fujifilm logo is in the middle, the chipped eye being a characteristic part since 2006. And here is a clue, a hint for discoverability, a hint of how to use this product and what this product is really for. This odd shape here. This is telling us something, begging to be touched and played with. And yes, our curiosity is rewarded. Those of you who have watched many of my videos know that I can't resist a good mechanical hinge. So fresh, so satisfying. And what's this? Dual lenses? These are the key to understanding how 3D photography really works. The lenses are spaced 75 millimeters apart, or 2.5 inches for my fellow savages, a bit more than the average interpupillary distance of 63 millimeters. So, two lenses, and here we have the text Twin CCD. CCD, or charge-coupled device, is a type of camera sensor used in high-quality imaging. So we have two lenses, two sensors, basically two complete cameras. All of this to create depth. Each human eye sees a slightly different perspective. For example, the left eye may see slightly more of this side, and the right more of this side. Then our brain, which is truly a marvel, uses the information to determine the distance to an object. Of course, this works best with two eyes, but even if you close one eye, the brain is so incredible at making inferences from the size, position, and lighting on objects that you still see some depth. But a 3D camera needs to take an image from 2 points to simulate the eye. If we move on to the top of the device, we'll see this premium chrome ring surrounding the camera, housing standard camera fare, a shutter button with a zoom ring, then on the left, a toggle. What is this? The Parallax control toggle, a part integral to the other big feature of this camera. Oh, you thought taking 3D pictures was enough? So let's take a quick step back. 2 lenses to take 2 pictures, right? So then we have 2 pictures. Wow, 2 pictures that are almost identical. Well, incredible. Not really. The trick is making it so that the left eye only sees the left photo, and the right eye likewise. Then we get a 3D effect. Normally, this is done with tricks, like the classic red and blue glasses, the colored lenses filtering out the parts of the picture meant for the other eye. This method of creating anaglyph pictures is one way to do it, but it can get a little messy and throw off the overall coloring of the picture. Then we have the method used in modern TVs and movies, polarizing filters that do the same thing, only they filter horizontal and vertical waves of light. So blocking by glasses is one way, but without them, we could cross our eyes like we're looking at a hidden image book from Magic Eye in the 90s. But here's a more sophisticated technology, a parallax barrier screen. This exact same technology is found in the Nintendo 3DS line of handheld consoles. Basically, there's a series of slits spaced perfectly to allow each eye to only see the part of the image meant for it, which creates the 3D effect. That toggle on the top, it allows us to adjust the degree of the 3D effect applied, which is just like the slider here on the 3DS. Too bad I can't show you through your screen, but it's pretty effective. However, it requires your head to be in exactly the right position to see the 3D effect, or it is just a blurry mess. The new Nintendo 3DS, great naming as usual, House of Mario, surprisingly does 3D viewing the best, using its camera to track your eye position and adjusting so that the 3D is viewable. Even on the 3DS though, viewing things in 3D flexes some muscles that I don't normally use when I see the world, i.e. it gives me a minor headache. But still, it's really cool. So that's the main stuff. There are a lot of cool features here for 3D picture taking. You can manually adjust depth, the level of 3D effect, camera positions, and make some pretty trippy effects. Many of the standard premium camera features are here as well, and it works as a regular 2D camera. We can even toggle off the 3D. But where's the fun in that? This camera is time capsule worthy. Nothing else is so quintessentially a product of a specific time, so niche and doomed to be forgotten. But that's the natural order of things. Things come and go. Maybe 3D will return in full force when new technologies make it even more accessible and easier on our eyes. Until that future, and until next time on Design of Things.